This short presentation is about finding n in confidence intervals for proportions. And n is our sample size. Sometimes we have a specified confidence level and a margin of error, but we don't know what size n that we're going to need to achieve that. So our goals and objectives for this particular lesson is that you're going to be able to find an appropriate sample size for a particular confidence interval with a particular margin of error, and then we'll go from there. Choosing the sample size, very similar to what we did for finding for means. Alright, so we have to find n. So in means we had sigma over the square root of n. You had to solve for n in that case. But for proportions we have one other problem, because p hat involves n. Well, we don't have n, so how do you get p hat? Well, we want to take an error on the side of caution, and so we're going to take and use 0.5, because that's going to give us the largest margin of error, and we're just going to use that as our guessed value. Now, if you have previous values from a survey or any kind of study that you can use for p hat, go ahead and use your p star as that previous value. But for most cases and most problems that we have in this textbook, we don't have previous values for p hat in those situations. So we will default to 0.5 for our p hat, and that's called p star. So if you look at the formula below, for our margin of error, we have z star, and then we have times the square root of p star times 1 minus p star over n. And so I want you to think about this for a little bit. Why does p star maximize when we use 0.5? So think about that for a bit. The problem that we have for an example tonight is one about two candidates running for mayor in a large city. Gloria Chavez, Ronald Flynn are the candidates. You're planning a sample survey to determine what % of voters plan to vote for Chavez. This is a population proportion P. And you'll contact a simple random sample of registered voters in the city. And you want to estimate P with a 95% confidence interval and a margin of error no greater than 3%, or 0.03. How large of a sample do you need? The winner's share in all but the most lopsided elections is between 30 and 70% of the vote. Okay, so that's not going to help us. So we're going to use a 0.5. Notice how we plug those values in to our formula, and we get the 1.96, which is our z star for a 95% confidence interval. And then in the second step, notice how we take the square root and we break it up to 0.5 on the top and times 0.5, and then we have the square root of n on the bottom. Then we switch proportions. We've got the 0.03 we take down to the denominator on the left hand side, we just cross multiply, and then we take the square root of n over to the numerator on the right side. Then notice in the fourth step down how we switch the inequality. And that's not necessary, but they do that in this particular case. You can keep n on the other side if it that is what you prefer. So we have the square root of n is greater than or equal to 32.66 repeated. Then they square each side, and they have n is greater than or equal to 32.66 squared, which is equal to roughly 1067.1. But since the number of people has to be a whole number, because we're dealing with folks here and voters, so we have to round up. So we have 1068 people will satisfy the inequality, and that'll give us a margin of error of 0.03 or less. Okay, so this is short and sweet, and I hope it makes sense. If you have any questions, you can ask me tomorrow, and have a good night.